Welcome to Modeling Mastery, the podcast where we explore the art and science of software design. I'm Hex.
And I'm Byte. Over the last several chapters, we've taken a deep dive into the tactical building blocks of DDD, the objects that make up our model: entities, value objects, domain services, and domain events.
We've defined the fundamental components. Now, in Chapter 9, Modules, we're going to talk about how we organize them. This isn't just about putting files in folders, it's a critical part of the design process itself.
That's the key insight of this chapter. In domain-driven design, a module, or a package in Java and a namespace in C# is not just a mechanism for technical organization, it's a first-class citizen of the model and a fundamental part of the ubiquitous language.
We'll explore how to name and structure our modules to tell a story about the domain, creating a model that is not only well-organized, but also deeply expressive and easy to understand.
We'll contrast this with the common mechanical approaches that can often hide the domain's true structure.
It's time to bring some meaningful order to our model. Let's get started. Every developer who has worked with Java or C# is familiar with the concept of packages or namespaces. We use them every day to organize our code, but domain-driven design asks us to elevate our thinking about them. A module, in DDD terms, is far more than just a folder.
It really is. And the best way to understand the DDD approach is to start with the common anti-pattern that the book warns against. We've all seen projects where the packages are named after technical patterns. Inside the domain layer, you'll see a package called aggregates, another called services, another called events, and so on.
This is what the book calls mechanical organization. It tells you about the type of code in the folder, but it tells you absolutely nothing about the business domain. All the concepts are scattered. If you want to understand everything related to a product, you have to jump between the aggregates package, the events package, and maybe a factories package. The structure hides the domain instead of revealing it.
The DDD approach is the complete opposite. The primary rule is that modules should contain a cohesive set of domain concepts, and their names should be part of the ubiquitous language. The book uses a great analogy of organizing a kitchen. You don't have a drawer for metal things and a cabinet for ceramic things. You have a drawer for cutlery and a cabinet for dishes. You organize by concept in purpose.
Let's look at how the Sassovation team applied this to their Agile project management context. The root package for their model is com.sassovation.agilepm.domain.model. Underneath that, they don't have folders for technical patterns. They have modules named after core domain concepts, team and product.
And it goes deeper. Under the product module, they have submodules like backlog item and sprint. This is so expressive. The full package name, com.sassovation.agilepm.domain.model.sprint, literally reads like a phrase from the ubiquitous language. It describes a sprint of a product in the Agile project management model. The structure itself tells a story about the domain.
This conceptual organization has powerful technical benefits. When you group cohesive domain concepts together, you naturally achieve low coupling between modules. The code related to a team and a product owner live together in the team module, and it rarely needs to know about the internal details of how a sprint is managed in the product.sprint module. The design encourages you to create boundaries.
It also means that the module structure itself is part of the design and should be refactored as your understanding of the domain deepens. If you realize that two concepts you once thought were separate are actually deeply related, you might merge them into the same module. If a module becomes too large and seems to contain multiple responsibilities, you split it. The module structure is not a static scaffolding. It's a living part of the model.
So the core principle is to treat your modules with the same care as your classes and methods. Their names are a vital part of the ubiquitous language, and their structure should communicate the conceptual contours of the domain. This approach moves us away from a purely technical organization and toward a model that is truly expressive and much easier for any developer to navigate and understand.
In our last episode, we established that our module structure should tell a story about the domain, with names that reflect the ubiquitous language. But a good module design is also about creating good fences, managing the dependencies between these modules to keep our codebase clean and maintainable.
Exactly. The book lays out a few simple but powerful rules for this. When we organize our modules by domain concept, we naturally start to see low coupling emerge, but we can be more deliberate. A key rule is to enforce acyclic dependencies between pure modules.
Can you break down what that means in practice?
It means that if you have two modules at the same level, say a product module and a team module, the dependency arrow should only point in one direction. The product module might depend on the team module to know who the product owner is, but the team module should have zero knowledge of the product module. If you allow them to depend on each other, you create a circular dependency.
And a circular dependency effectively merges those two modules into a single, tightly coupled component. They can no longer be changed, compiled, or tested independently. You've created a mini big ball of mud at the package level, which is what we're trying to avoid.
The book is pragmatic here, though. It acknowledges that this strict rule is often relaxed for parent-child modules. For example, the parent product module might contain a factory method that creates objects from the child product sprint module, and the sprint object will likely hold a product ID to reference its parent. This small localized circular dependency is often an acceptable trade-off for a logical and expressive structure.
This principle of organizing by domain concept extends beyond just the core model. It also applies to the other architectural layers. For instance, in the application layer, instead of having one giant services package, you might create application.team and application.product modules to hold the team service and product service. This organizes your entire application stack by business capability.
This leads to a really important strategic takeaway from the chapter. It helps us answer the question, when should I create a whole new bounded context versus just a new module?
That's a critical architectural decision. The book's advice is to favor a module first. A module is a thinner, more lightweight boundary. If you're uncertain whether two domain concepts are truly separate or just different aspects of the same whole, your first step should be to separate them into different modules within the same bounded context.
This allows you to explore their relationship without the significant overhead of creating a new deployable unit, like a microservice. You then watch how these modules evolve over time. If you find that they are developing their own distinct vocabularies, their own ubiquitous languages, and that the dependencies between them are few and simple, that's a powerful signal. It tells you that these concepts have matured and are likely ready to be promoted into their own separate bounded contexts.
So modules are more than just organizational tools. They're a way to enforce healthy dependencies, and they serve as a strategic pattern for iteratively discovering the true boundaries of your domain. They are the first line of defense in keeping your model clean.
We've focused heavily on how modules organize the core domain model, but the book makes it clear that this principle of naming by concept should extend to the entire application architecture. The structure of your domain should influence the structure of your whole system.
Absolutely. Let's take the application layer. Instead of having one giant services or application package, it should mirror the domain structure. If your domain has product and team modules, then your application layer should have an application.product package containing the product service and an application.team package for the team service. This organizes your application's use cases by business capability, which makes the entire code base much easier to navigate and understand.
The same logic applies to the infrastructure layer. The implementation of the product repository could live in infrastructure.persistence.product, while the team repository implementation lives in infrastructure.persistence.team. This keeps the concrete persistence code for different domain concepts separate and organized. The conceptual boundaries of the domain radiate outwards into the technical layers.
This clean, logical organization has a massive payoff with modern deployment strategies. A well-designed DDD module with clear responsibilities and low coupling is a perfect candidate to be packaged as a physical deployment module, like a Java 9 module or an OSGI bundle. The good logical design you perform upfront enables you to have more flexible, independent deployment options later.
Let's ground this in the SAW Ovation case study. In their agile project management context, the team settled on high-level modules that reflected their core concepts: tenant, team, and product.
And inside the product module, they didn't just dump everything. They created sub-modules for backlog item, release, and sprint. The book points out this was a very deliberate decision. They considered putting all four related aggregates, product, backlog item, release, and sprint, into a single product module. But with all the associated entities, value objects, and events, that would have resulted in a single package with nearly 60 classes. It would have been a disorganized mess.
So they made a practical trade-off. They accepted a small amount of coupling between the parent product module and its children in exchange for a huge gain in clarity and organization. It's a perfect example of how module design isn't about following rigid rules, but about making conscious decisions to best express the structure of the domain.
It really drives the point home. Good module design is an active part of the modeling process. It's a tool we use to manage complexity and ensure that the conceptual clarity of our ubiquitous language is reflected not just in our class names, but in the very structure of our entire application.
As we conclude our discussion on Chapter 9, it's clear that modules play a much deeper role than just simple code organization. They are a design tool in their own right, shaping how we understand and interact with the model.
The most critical lesson for me is the deliberate rejection of mechanical organization. That habit of creating packages named controllers, services, and repositories is so ingrained in many frameworks. The DDD approach forces a mental shift, organized by the concepts in your ubiquitous language, like product and team. This makes the domain, not the technology, the primary organizing principle of your entire application.
This conceptual organization provides the technical benefits of low coupling and clear dependencies. But the most profound takeaway from this chapter is a piece of strategic advice. Use a module before a bounded context.
This is such a pragmatic and powerful heuristic. It addresses the real-world problem of dealing with fuzzy boundaries. Often, you're not sure if two concepts are distinct enough to warrant being in separate microservices or deployable units. Instead of making that big, high-cost decision up front, you start by separating them into different modules within the same bounded context.
It's an iterative approach to discovering your architecture. A module is a lightweight logical boundary. You can use it to test the separation. Over time, you observe how the two modules evolve. Do they develop their own distinct language? Are the dependencies between them minimal and simple?
If the answer to those questions is yes, then the domain is telling you that a harder boundary is needed. The modules are ready to be promoted into their own separate bounded contexts. This turns a massive upfront architectural decision into a gradual evidence-based process. It's agile architecture at its best.
So, to summarize, well-designed modules provide multiple benefits. They make the model expressive and easier to navigate. They promote healthy, decoupled dependencies. They enable flexible deployment strategies. And they serve as a crucial tool for discovering the true strategic boundaries of our domain.
They are the pattern that organizes our tactical building blocks in a strategically meaningful way. This concludes our look at modules. Next time, we're diving into one of the most challenging and most important patterns in DDD, the aggregate.
That's right. We'll be talking about consistency boundaries, invariance, and the rules that govern how our domain objects can be safely changed. It's a topic that sits at the very core of tactical design.